So basically, what are Unix files? So files are basically the building blocks of any operating system, right? So any operating system you talk about, so basically everything in any operating system is all about files. Ports are also treated as files, directories are also treated as files, everything is treated as file structure only. So every details of everything are basically stored in files. So basically, what happens in here is that what happens that when a user executes a command in Unix, when a user executes a command in Unix, what happens? The Unix kernel finds the particular executable file related to that command and loads it into the instruction text of the memory. Means it created a separate process containing the binary file of that command, and it creates the process to execute the command on its behalf. So whenever you are typing any command, ls, cd, so basically on its behalf it is taking the command and it's running the system. So a file in a Unix or a POSIX system may be one of the following types, right? So basically, Unix and POSIX are two different file systems, but they are basically belong to something this one only. So Unix systems only. So there is a POSIX architecture is there and a Unix architecture is there, right? So there are following types. The files can be regular file, it can be a directory file, it can be a first in first out file, it can be a character device file, it can be a block device file, right? So what is a regular file? The text or binary file. It can be both executable with a suitable permission. And how to create it? You can create it using BI editor, right? You can create a regular file using the BI editor. And how to delete that file? Using the remove command, rm command, right? Now, what is a directory file? Directory file is basically the folder on which every basically the all the other files contains. So in Unix, everything is considered file. Even the directory is also considered as a file. So it has a in Unix, it has a unique tree structure, and how to create using mkdir command, make directory command, and how to delete a directory using the rm directory. That is this one. So we can also display the contents of directory using the ls command. So whatever the contents in a directory here, we can display it using the ls command. So the another is the first in first out files. So it is used in inter-process communication. So if you want to create one file, so for basically from passing information from process one to process B using this buffer, so you have to create a pipe or name file using the make FIFO. So like this one, you create this file make FIFO user Sunil FIFO underscore pipe, and okay. And this make me a node that you can create using this one. So make FIFO and make node is used to create a basically a buffer file for transferring information between process to process. The user Sunil FIFO pipe. So these are used. So what are device files? So files are block and device files. So character device files. So automatically when you are inserting in your floppy disk or your this one USB port, so automatically a block or device file is created, right? So basically you can also create your own character device files by using the make node command. Okay, so you can open a basically so let us say you want to create a file one and make node. You created a node in this one. Use the node Sunil file, and the device port number you have given is 115 and 120. In this way, you can create the device files. I have not worked on one of these device files, but you can certainly try. So major device number is the index to the kernel table, which device driver function addresses. So basically, if you are basically it's a Unix is what you can say is an open operating system where you write different commands, where it's basically the different commands can be outsourced. And there is a minor device number where integer number that is parameter to the device divider function. Right. So basically, so basically Unix is open, so that means you can modify anything within that Unix system, right? You can write the different commands or different codes for this purpose. So whenever you are creating a major device file, what you are doing is basically you are creating first one of the file that you created for a device, and the next thing you do is that you create a index number to the kernel table about that device driver function addresses, whatever the device driver file function address is. And the second thing that you open create is minor device number, which is the integer number that is the parameter to the device driver function. So if by what you can call by referring to this minor device number, you can link to this particular device. So basically, if you are creating a new device and you want to link out to it, so you can use the make node file. Then there is the symbolic link files, which is supported by Unix but not by POSIX. So it contains a path name that refers to another file system. So basically, what is this? Basically, symbolic links. So basically, it represents a particular file through a particular symbolic path. So that file can be within your system or it can be outside the system also. That it can be in some remote server. But you can access it using the symbolic link or basically the command name to access that file. So basically, Unix and POSIX file systems are something basically there some similar structure is there. They have a tree-like hierarchical file system. There's a name max, path max. There's a POSIX name and path. There's a hard link. So hard link and basically what you can say a symbolic link we will come into the difference and understand it together. Right? POSIX name and path. So these are the different what you can say attributes of a basically a file within the Unix and the POSIX file system. So these are the different types of files that are there. So /etc is the store system administrative files and programs. /etc/password stores all user information. /etc shadow stores all user passwords. /etc/group stores all group information. /bin stores all system programs like cat, rm, cp, all these things. /device stores all character device and block device files. /user include stores all standard header files. /user lib stores all standard libraries. /tmp stores all temporary files created by program. So the what is the Unix and the POSIX file attributes? So what is the file type it is that is specifies what type of file it? আচ্ছা এখন পর্যন্ত কোনো কোশ্চেন আছে তোমাদের? Hello?
না স্যার।
You are understanding, right?
ইয়েস স্যার।
কোশ্চেন থাকলে করো, কোনো অসুবিধা নেই। এটা নয় যে আমি তোমার উপর খুব মানে কঠিন কোশ্চেন জিজ্ঞেস করবো সেরকম কিছু না। Nothing like that. Okay. So the Unix and POSIX files attributes is basically we want to know what is the type of file, that is file type specifies the what type of file it is. What is the access permission to a file, that is a file access permission to owner, group and others. What is the hard link count, that is the number of hard link to the file, that is the user ID, that is the who is the file owner. What is the group ID and what is the file size in bytes. So anything information you need a file, you can find this in here. So in here, this inode number is basically an index to a particular file. So the Unix file attributes is follows in these numbers. So basically, the system or inode number of a file. So basically, the index of a file is stored as an inode number in a particular table. The file system ID is where the file system file is stored. So where the file is stored, you have a file system ID. What is the last access time to a file? What is the last modified time of the file and what is the last change of the file. So these all information are stored in here. So these are the different commands which can change the ownership or basically change the access type of your file. So one of the particular command is change mode file, which changes the access permission, last change time, all these things are changed using the change mode command or ch mode command. Ch own command is the changes the user ID and the last change time. Change group changes the group ID. Touch changes the last access time and modification time. LN or link increases the hard link count. RM basically decreases the hard link count. One second. Decreases the hard link count. Basically, hard link basically represents a particular number to what is the particular number of files are there in a system, right? And when you are and when you are removing one file, it basically decreases the hard link count. So if the hard link count is 0, the file will be removed from the file system. So VI Emac is basically changes the file size, last access time, last modification time. So these are the commands which changes this. So inode table keeps tracks of all files, and inode record basically attributes, inode number, physicals. So all these things are stored in here. It's a unique ID. So you all know about directory files. So in Unix, everything is a directory only. So basically, in the so directory is also considered as a file. So directory is a record-oriented file, record data type of start direct or an Unix file, and for this one the start directly. So this is the thing. Basically, the record of the information is stored in Unix file. So these are system-specific commands. So you don't need to remember this one. So all the record data types, all basically metadata information regarding a file can be stored in the this directory or the folder information, right? So what are the directory functions are there? That are different directory functions are there. That is open directory, which opens the directory file. So re-add directory, it reads next record from the file, right? So directory is also considered a file. So the commands in here is open directory means opens a directory file. What is the next record from the file? That is also can be taken from the read directory. Close directory is basically closes a directory file. Reviewing directory key sets file pointer to the beginning of it. So these are done by the directory. So what is a hard and symbolic link? A hard link is a Unix path name for a file to create hard link in command for a file. The hard link is a Unix path name for a file, right? To create a hard link, the command you use is ln slash user abc old dot c slash user xyz new dot c. So basically, so it creates a hard link to the file. So basically, if you are accessing a hard link, it basically represents the file also. Symbolic links also means a referencing, but symbolic links refers to a basically referencing file, right? So if you want to create a symbolic link, you have to use the command link minus s, right? And it will create a reference link to this particular file. So what is the CP and the link command? CP command creates a duplicated copy of the file to another file. So if you are creating a copy paste, like in Unix, you are using CP command for the purpose of copy pasting a file, right? So the original copy also remains, the duplicated copy also remains. But in a link file, save space by not duplicating the copy here, the new file will have the same inode number as the original file. So the new link to the this one to the original file is basically same. So basically, if you delete one file, so they defeat the inode number, you delete the original file. So that is the basically difference. So one copy, if you delete one copy, another copy depends. But in link command, if you create this hard link, you delete the hard link, the whole file is deleted, even if there are two hard links. So basically, application program interface to the files. So basically, files are identified by path names. Files must be created before they can be used, and you have to use the open system call to return a file descriptor. So what is the open max command? It is for reading and writing. So all the statistics data or file statistics data or file attributes can be taken from this command stat and fstat. File attributes can be changed using change mode command, which you have seen earlier, change on or u time, what is the access time, the link system calls ln that you have learned earlier. Hard links are linked removed by unlinked system call. So if you want to remove any hard link, you can use the unlinked system call. Any question till now? এই কোন কোশ্চেন তো জিজ্ঞেস করো, ডিসকাশন না করলে কিভাবে পড়াশোনা হবে? না ঘুমোচ্ছ সবাই?
না স্যার, এখনো অবধি তো বুঝতে পারছি।
বুঝতে পেরেছি স্যার এতক্ষণ।
ওকে, ঠিক আছে। So basically, whatever the statistics, right? So basically, any file has some file attributes to it. And what are the file attributes of a file? So it has a system ID, it has the inode number, it has a type and access flag, it has a hard link, it has the user ID, it has a group ID, it has a major division and minor division, it has a file size, it has the last access time, last modification time, and last change time. So all things information are using the structure information, right? In the in the struct user data type, you can store all the information about a file. If they are already, you can access them. So what is the Unix kernel support for files? Unix executes a command. So this is a process, right? Unix executes a command, a process kernel or command execution. Process data structure, file descriptor table is one of them. So whatever the related information to a process, so basically everything is in file. So in a binary file is executed, so everything is data structure is also basically executed. So whenever you are opening a file, you have to open the its file descriptor to understand whatever its entries are, and whatever it records all, and it records also basically everything about the file opened. All the files that are open in the system are this kept in the file descriptor table, right? And it records all files opened by the process for a particular process. So kernel support to open system call. Whenever open function is called, kernel will resolve the path name to a file inode, right? So basically, if you are in C, if you are writing f open, right, for a particular file name, so that path name is basically linked to the file inode, which is basically the link to the actual hardware link to the actual file. Hard link means where it is stored in the basically secondary memory. So basically, this is the file descriptor table. Okay, and this is the file table, and this is the RC1 inode table. So so in the file descriptor table, process opens. So the all the files opened by the process are stored in the file descriptor table. It goes in the file table where it searches the names, and from there it finds the actual hard link of the file or the entry of the file in the file system in the inode table. The kernel will search. So basically what happens in here, whenever a process opens a file, the kernel will search the file descriptor table and look for the unused entry, which is written as the file descriptor of the open file. The kernel will scan the file table, which is used to reference the file. If an unused entry is found then the process file descriptor will be set to the point to the file table entry. The file table entry will be set to the point to the inode table entry where the inode record file is present. So it will be linked. So this will how the basically the whenever a process is opening a file, this is how the inode file that is there, which is actually the link to the original file in the basically hard disk, that will be linked to the original in the process file, right? The file table entry will contain the current file pointer of the open file. The file table entry will contain an open mode which specifies the file open for read only, write, etc. Reference count of file is set to 1. The reference count of in memory and node of file is increased by 1. That is how the system basically works. So kernel support is basically read system call. The kernel will use the file descriptor to index the process of file descriptor to find that file table entry or to the open file. It checks the file table entry to make sure that the file is opened with an appropriate mode, right? The kernel will use the file pointer. So appropriate mode, which is the executable or read mode or write mode, that is the file that the kernel support will check. The kernel will use the file pointer used in the file and table entry to determine where the read operation should occur in file. Okay, not much is left, so we can complete this one. The kernel will check the type of file, right, in the inode record and invokes the appropriate driver function to initiate the actual data transfer to the physical file, right? The kernel will check the type of file and basically when it fits the read, so it will do the actual driver function to read the file from the secondary disk. If the process calls lseek info function when the changes are made provided the file is not a character or device file, a FIFO file or a symbolic link, as they follow only sequential read and write. So basically, as per the command, the particular changes are made to the file. If a file is basically sequential information, then that is how the command works for a particular file. So the kernel, whenever you are opening a fopen file or if you want to read write a file, that is how the kernel provides you the support through a series of links from the process open file to the file table and then to the inode table. So whenever you are doing a closed system call, whatever will happen, the kernel will set the corresponding descriptor table to be unused. So basically, within the file descriptor table, that entry where the file was open, it will be unused. It will be the pointer will be set as unused. It decrements the reference count of the file table by 1. That means whichever file table entry was there, so basically the count, the number of files are open, so it is decremented by 1. The file table mark is marked unused. The reference count in the file inode table entry is by 1. It reference will then go to 6. So let us see go to 6. So it basically success status. If hard link count is non-zero, it returns a success status. Otherwise, mark the inode table entry as unused and deallocates all the physical disk. So whatever is there, so it is The inode also called table is also basically all the entry to the open file access are basically removed from the three parts. That is that is the file descriptor table also it is removed, file table is also removed, inode table also it is removed. One second. This is where we open, right? Okay, the file table is remain absolute. The reference count on the file inode table entry is marked by in the file marked in by 1. If reference count is not equal to 0, then go to 6. Means it will again go to the success. If hard link count is non-zero, it returns a success status. Otherwise, marks the inode table entry as unused and also deallocates all the physical disk storage that is there for it. So these are, if you are opening a file in the C program, so these are all the functions which are basically used to read and open a file in the directory. Open, read, write, exec, close. Okay, understood? Hello, hello, বুঝতে পারলে?
ইয়েস স্যার।
Yes,
হ্যাঁ
sir.
স্যার।
তোমাদের তো মনে হচ্ছে ঘুম পেয়ে গেছে।
না না স্যার, আপনার পিপিটিতে সব লেখাই তো ছিল।
আচ্ছা ঠিক আছে, তো তোমরা একটা কাজ করো, তোমাদের রোল নাম্বারটা দিয়ে দাও আর আমরা আবার 3টের সময় তোমার একটু প্র্যাকটিক্যালটা দিয়ে দেবো। প্র্যাকটিক্যালটা সোজা আছে, তোমরা আগেবার করেছো, তোমরা জাস্ট এবার এটা করে দিও।
ওকে স্যার।
রোল নাম্বারটা লিখে দিও।